Hello everyone. So I come back with section 3.5, implicit differentiation. So in this session, we will start with an equation over here. X squared plus y squared equal to 9. And as you can see, this is an equation of a circle. Okay. And this circle have the radius as the radius is 3, and center is at 0, 0. Okay. And now I would like to ask you: is this a function? Okay. I call it this equation. Everyone heard that, but I want to ask if this is a function, right? So in order to check if it is function, you can use vertical vertical line test. So let's draw a vertical line, and as you can see, for this vertical line, it's not really vertical, but let me try one more time. Okay, it's better. So for this vertical line, how many intersection of this vertical line with the graph of the equation x squared plus y squared equals 9? So you can see there are two intersections, right? So since there are two intersections, you can say this is not a function, right? So according to the vertical line test, so you see that there is two intersection. So then this is not a function. Okay. So now I'm gonna try to isolate y in the equation number 2, right? So let's isolate it. I have y equal to let's say y squared equal to 9 minus x squared, right? You subtract both sides of x squared, so you have 9 minus x squared, and then from here, if you do square root both hand side, right, you will have two cases, right? One is y equal to positive of square root 9 minus x squared, and the other one is y equal to negative square root 9 minus x squared. And below here is a graph for each equation, each solution for y, right? So the left hand side we're gonna call it top half of the circle, and the right hand side gonna give me the bottom half of the circle. Okay, so let's move up and see. So y is a function of x on the top half of y is a different function of x on the bottom half. So so these two, they are different. They are function, like for each. So the left hand side is a function. The right hand side over here is also a function. But if you combine them to become a circle, then it's not a function. Okay. So and And yeah, this is two graphs of the function, and when you glue it together, then you create the circle. Okay, so then we say that the equation number 2 defines y as a function of x implicitly. Okay. Okay, so in the following example, I'm going to have y is an implicit function of x, either because it would be impossible to isolate y and write y equal to stuff involving x, or like a function of x, or because the graph is actually two functions glued together. Okay. So, for example, the first one over here is these two function glue together as with y equal to positive or negative square root x minus 2. Okay. So what about the middle function? No, the middle equation is two function glued together y equal to positive or negative square root of 1 minus x squared over 9. So you can try to subtract x squared minus 9 over 9 and then square root it, right? So and the last one, you have x cubed plus y cubed equals to 6 xy, right? So can you isolate y? You cannot, right? So I said I can't isolate y. So, or you can say you cannot write y equal to a function of x, right? You cannot write y equal to a function of x because you can you may think about like subtract x cubed both hand side, but you see that the right hand side will still have a function with y. Okay, so so how do we take the derivative for an implicit function, right? Okay, so so consider x squared plus y squared equal to 9 as a whole circle again. The curve has a tangent line at x point. To get the slope of the tangent line, we need to calculate the derivatives. Okay, so let's have example 20. Calculate the derivative of x squared plus y squared equal to 9. And remember that our goal is to come up with an expression for dy dx. Okay, so we are take the derivative of y with respect to x. What we do is first differentiate both sides. So what I do now, let me show you. Dx of x squared. That is the first one, first term. Plus d over dx of y squared. Okay, equal to d over dx of 9. Okay, let me see. 9. Okay, so from here you can see that this guy will be actually, you know what? Let me use other color. This one go to 0, right? Because a derivative of constant will be 0, right? Okay, so now let's see. For the next step, you're going to use the rules for differentiating x and y differently. Okay, so you're gonna think that y as an implicit function of x. Okay, y as an implicit function of x, and what does that mean? Y will be equal to yx, like a function of x, and x in here still is still is x. Okay, um, and then we had to, that means what we had to use chain rule for differentiating the y term. Okay, so what does that mean? Let me show you. So the first term here will give you 2x, right? Easily, right? Because x squared derivative will be 2x. Okay, plus now taking the derivative of y squared. Okay, y squared, you need to use chain rule. All right, so this is a function of x. So you're gonna write as 2y to power 1, right? And that is the outside derivative. You multiply it by inside derivative, which is y, d over dx times y. This is the derivative of y, derivative of inside function. Or sometimes it's called just, just dy dx, right? And the right hand side equals 0. Okay, let's move. Okay, so the last step is just solve for dy dx because we are looking for it. Okay, we are looking for the dy dx. Let me use other color. So we are looking for this guy. Okay, so to solve it, you need to subtract both sides by 2x. Okay, subtract both sides by 2x. So we have 2y dy dx equal to minus 2x. And then lastly, you divide by 2y both inside. You have dy dx equal to negative 2x over 2y, which will be equal to negative x over y. So you have conclusion as dy dx, or derivative of y with respect to x, equal to negative x over y. And that should be the answer for this example. And notice that the derivative here depend on the value of x and y instead of just x. Okay, and it is because of most x value we get 2y values, and the curve that different slope for each one. Okay. All right, let's move to example 21. We want to calculate dy dx at the point 1 square root 8 and the point 1 negative square root 8. Okay, so you can see in the picture down here, this is 1 square root 8 and this is 1 negative square root 8, right? So we want to calculate the slope of the tangent line at this point. So let's see what we can do. Firstly, we need to write dy dx at, this is at 1 square root of 8. So remember that this dash, that mean, let me do that. This that mean here, like at point x comma y over here, okay? And it's gonna be equal to what? So it was let's see. So it was according to the above example over here. You see, we consider x squared plus y squared equal to 9, right? So we have dy dx will be equal to negative x over y, which you can substitute as negative 1 over square root of 8, right over here, right? Yeah, you can see that it should be a negative number because from the picture, the tangent line is going down over here, right? So that is the reason why the slope has to be less than 0. Okay, so you have dy dx at this point has to be at 1 over or at 1 square root 8 has to be less than 0 or negative. Okay, so let's check as dy dx at 1 negative square root 8. So you can see that will be the color negative 1 over negative square root of 8 will equal to 1 over square root of 8, and that should be greater than 0 because the function not the tangent over here at 1 negative square root 8 is going up, so that means slope has to be positive, right? Okay, so let's move to the next page. So I have exercise to try number 16. Okay, so we still in the number 16 here, we're still talking about the circle x squared plus y squared equals to 9. What we do in here is we did have, according to the example above, we did have the tangent line slope is given by dy dx equal to negative x over y. So the question here is, at what point is the slope of the tangent line horizontal? Remember that slope of the tangent line horizontal is mean dy dx equal to 0, right? So then from there, what can you do? Okay, so I would that's my hint for this problem. Go ahead and do it. If you still cannot do it, let's talk about it in the class. For part B, at what point is slope tangent line vertical? Okay, so for the vertical tangent line, it's going to have undefined slope. So remember that undefined slope that would make the fraction undefined, And when a fraction undefined is the bottom has to be or the denominator has to be equal to 0. So like denominator has to be equal to 0. So that will make the dy or dx undefined. Okay. Okay, so that is what I give you. That is a hint I give you for this problem. But you still cannot handle that. We're going to talk about that in the class. And now see, at what point is the slope of the tangent line equal to 1? Again, this gonna give you dy dx equal to 1. And you're gonna try to solve for x and y in this case, okay? So we're gonna go to part D over here and find the equation of tangent line to the equation x squared plus y squared equal to 9 at 1 square root 8. So in here, what is slope? Because you are finding the equation within the line, right? So you need to find the slope first, right? It is equal to negative 1 over square root 8. That is from example 21. Okay, like okay, I'm gonna say from previous example page. Okay, so you can see that's slope or dy dx. So dy dx at 1 square root 8 equals to slope for the quotient line. And then now you're going to just using the formula that's y equal to y div at 1 times x minus 1 and then plus with y 1, and try to figure out for each for like y div 1 I have already, and what is y1, just think about it, right? I actually, this is a given already, so try to, this is my hint for you, try to figure out what you're gonna put in it easily. Okay, so let's move to the application over here. Okay, so suppose you have a string of length 3 feet tied to a ball. Okay, you grab 3 feet tied to a ball. So this from here to here is 3 feet, right? And you grab the rope and start spinning the position at the ball from the viewed from the top is shown in this animation. Okay, let me see. Take a look at the animation, right? Okay, click on this one. Oh, okay, so let me use open a new, let's see. Okay, so it look like okay, so it's spin like this. Okay, cool. So yeah, so so like a circle, right? When for example, so like you have for example, you have like a, yeah, you are, so you are here, you're here, right? And then yep, spinning the ball, something like that, right? Spinning the ball like that. Okay, cool. And okay, let me see. Okay, spin with that. Okay, and then what's the question? Come back. from here. Okay, so let me let me just try to draw over here for you guys. See, so person, right? Okay, I have this one, and okay, so here is bars, and yep. Okay, so it's like so it's spinning like a circle. So and the question is, suppose you release the rope at point x equal to 1. Okay, and y equals to square root of 8. Okay, so what is trajectory of the ball? Okay, so remember that this in the mathematics, this consider as a circle with let me see, 1, 2, 3, 3 feet. Okay, yep. So 3 feet over here, circle, and at the point 1 square root of 8, the bars will have the bars. Oh, the bars. No, I see here. Okay, let me. Oh, shoot. Okay, let me. So I have to redraw it. Okay. Okay. So. Okay. And then the ball follows the tangent line. Yeah. And the follow lines is and then it's going to be y equal to negative x over square root 8 plus 9 over square root 8. So so I can have these functions. These tangent lines from the previous problems over here. After you finish this equation of tangent line, you will have this is a tangent line of this case, and okay, and then what else? Oh, okay, yeah, because the question say, what is the trajectory of the balls? It's actually mean like what the ball gonna follow. How can you know the way the ball gonna go? So so I mean, you can say the ball follows a tangent line at that spot. It just try to go like that's tangent line, and yeah, and this should be the answer of this question. Okay. All right. So let's move to example 22. What we do is we're gonna find the y derivative if I have x cubed plus y cubed equal to 6y. So for this problem, you have to take derivative both hand side, take the d dx both hand side. Okay, so d dx for both hand side. Okay, so let's look at this. X cubed plus y cubed equal to d over dx of sigma. Okay, so now you can have dx the x cubed of dx derivative of x cubed respect to x plus with the derivative of y cubed respect to x and derivative you can leave the 6 out of here and then derivative of y respect to x. Okay, so let me go ahead and try to simplify for this. I have the x cubed or the root of x cubed over the x. It's going to be using the power rule. You have 3x squared, right? That's for the first term. Okay. And plus with y cubed, the root of the y cubed over the x. So so for this one, we know that y is a function of x. So I will write as say 3y squared times with dy dx. Okay, and then equal to 6 times dy dx. Okay. And lastly, I have 3x squared what I do is I'm going to subtract both hand side. You know what? I'm going to rewrite dy dx as y derivative. Okay, so let's write as 3y squared multiplied by y derivative like this equal to 6y derivative. So I mean they're the same, but I just want to write like that. So you can see it's like, you know, more short, and maybe you can easily to see the way I can isolate the y derivative later on. Okay, so because I want to isolate this. Okay, I want to isolate the y derivative, right? So I need to separate them in one hand side. I separate all the terms that have y derivative in one hand side. Okay, so what does that mean? I wanna subtract both hand side by 3y squared times y derivative, right? Minus 3y squared times y derivative. Minus 3y squared times y derivative. And now you have 3x squared equal to 6y derivative minus 3y squared y derivative. And now you can rewrite it as 3x squared equal to, okay, try to separate the y derivative. What does that mean? In this case, you need to factor the y derivative alone. I mean, you need to factor the y derivatives, and then later on, you're going to separate it alone. Okay, so factor the y derivative. So we have the first term is x, and the second term will be 3y squared. Oops. Okay. And lastly, you're going to divide both hand side by divide both hand side by 6 minus 3y squared. 6 minus 3y squared. You will have 3x squared over 6 minus 3y squared equal to y divided. It is the one that I need for this product, right? Because the question say find the y divided, and now I have the y divided is negative 3x squared. Well, actually, you know what? I will factor 3 out, and let me see. I can still simplify it. So if I factor, okay, so let me write as y divided equal to 3x squared over 3 times 2 minus y squared. And then now you can cancel out the 3 on the top, common factor with the bottom. So now finally you have y divided gonna be x squared divided by 2 minus y squared. That's the answer. Okay. So far, so good. We have finished page 18. Let's move down to the next page. This talking about invert trigonometric function. I would love to talk about this in the next video. Okay, so let's stop this video here and see you later. Okay.